Hi, I'm Paul. We are doing Leetcode must-know interview questions. Today's question is, or today's challenge is, remove nth node from end of list. Given the head pointer of a linked list, remove the nth node from the end of the list, return the head of the list. All right? Any constraints to be aware of? Okay, we'll come back to that. Okay, let me give you a formula here. I need a pen. All right. So the formula is this: K minus N plus 1. All right. That tells us, counting from the front of the list, what node do we want to, what node do we want to remove? Because we have no, it's a singly linked list. It's only linked forward, so we can't start at the end of the list and count n backwards. So if we want to know, counting forward from the end of the list, what node do we want to remove? It's K minus N plus 1. I'm not going to do a proof of that, but I mean, you can work it out. K in this case, which we don't know, is the length of the list. But I can give you an example of how it works, because in the example here, we do know what K is. It's 5, and we know what N is. N is, I should have scrolled it a little bit first, but N in this case is 2. Remove the second node from the end of the list. So 5 minus 2 is 3, plus 1 is 4. We want to remove the fourth node from the end of the list. All right. How can we do that? I'm going to turn the drawing off for a minute. Let me look at the constraints one more time. Number of nodes is SZ size. It's between 1 and 30. Node val is not that important. N is between 1 and size. Okay, that's important, because if n equals the size of the list, it's kind of a special case. Follow up: could you do this in one pass? We could do it in one pass. So let's do it like this. Let's say we have 2 pointers. We're going to start with what we'll call the fast pointer. All right, fast pointer is the head of the list, points to the first node, and we're going to move it forward n nodes. So it's going to go to here, and then it's going to go to here. All right, because we know what n is. In this case, n is 2. All right, let me erase those other pointers. Now let's add a second pointer. Second pointer also starts as a pointer to the head of the list. Okay, now the number of nodes that we would have to move this first pointer to get it to the end of the list, and by end of the list, I don't mean node 5, I mean the end of list indicator, which is the next pointer of node 5. So to get to the end of the list, it would have to move forward three times. And once we've got the pointer set like this, with the slow pointer pointing to the first node and the fast pointer advanced n nodes, if we move them in sync, If we move the third pointer 3 positions, which, as I said, is what it's going to take to get this first pointer to the end of the list, it's going to wind up going here, 1, 2, and 3. And so now it points to the node that we want. Once the fast pointer equals null, the slow pointer is going to point to the node that we want. And we're going to do that a little bit differently. We're actually going to iterate until fast pointer dot next equals null, in which case we would only have to advance it two positions. We would have to advance I just need the color change. We are going to advance the fast pointer to here, where fast dot next equals null. We advanced it 2 places, and so we're going to advance the slow pointer 2 places, and it's going to point here to the node before the node that we want to remove. And actually, that's good. Let me erase some of these other pointers. It's good because in order to remove a node from a linked list, you need to be pointing to the node preceding that node. The way that you remove the node is you change the next pointer of the 3 node and you replace it with the next pointer of the 4 node. Well, the next pointer of the 4 node points to 5, so we'll change the 3 pointer to point to 5, and 4 goes away. There's one special case here, which we'll see in the code, but the special case is if we start with, let me go back to the white pointer. If we start the fast pointer here at node 1 and we move it forward 5 positions, for example, if we get this list and we get n equals 5, we want to remove the 5th node from the end of the list. 5th node from the end of the list is this node right here, 1. So n equals 5, we move forward 5 positions. 1, 2, 3, 4, and 5. And we are now at the end of list null indicator. Okay. If after this first iteration the fast pointer equals null, then we know what we need to do is remove the first element of the list. So all we do is change the head pointer to head.next. Head is currently pointing to 1. 1.next is currently pointing to 2. So we just change the head pointer to point to 2 and return it, and the first node is gone. All right, so let's see what that looks like in an implementation. All right, as we said, we're going to have 2 pointers. We're going to have a pointer called fast, initially pointing to the head of the list, and we're going to have a list. We're going to have a pointer called slow, also initially pointing to the head of the list. All right, we move the fast pointer for int I equals 0, I is less than n. As we said, we're going to move it forward n positions. Okay, so then fast equals fast dot next. The special case, kind of the edge case, is that if we have run the fast pointer all the way to the end of list indicator, that means that n equals the length of the list, and what we want to do is to return the I'm sorry, remove the first node. So head equals head dot next, and we'll return it. Return the head node. All right. If n is less than the length of the list, we're going to do a loop and say while fast dot next is not equal to null. That is, we're going to iterate it all the way to the last node in the list, the fast pointer. We move these pointers in sync now. So fast.next equals, no. Fast equals fast.next, and slow equals slow.next. At this point, the slow pointer points to the node prior to the node that we want to remove. So we just swap the pointers and say that slow.next equals slow.next. And return the head pointer. Okay. Looks all right. Let's try and run it. All right, basic cases are working. Slide this over so we can see it. And submit. Where are we here? Runtime. It doesn't show a chart for the runtime. That's kind of weird. I guess like everybody got the same runtime. I mean, there are other ways of doing this, you know, not in one pass. You know, you could go through and count the number of nodes in the list, but anyway, so everybody gets 100%. The memory, I'm surprised that well, I don't know. Let me see the memory again. The memory, God, we're way out there. But the memory, it's just I don't know. It's one pass, so this is O of n, right? What's the memory? Is it O of n? O of 1. Oh, it's even better. That's right. Well, actually, yeah, we didn't even create any new nodes. It's just pointers. All right. It's a little disappointing on the memory, but it still goes in the record books as a win. So that's it. Hope you enjoyed it, and feel free to like, subscribe, comment, and we'll see you next time.